There we go. 2.2, Chapter 2 is going to start off with some patterns. But before we deal with patterns, I need to define a word for you, and that word is perimeter. You need to know what perimeter means. And so let's write down what a perimeter is. A perimeter is the distance around the outside added up. The distance around the outside. If I want you to find the perimeter, all you have to do is add up all the outside. I'm just going to write that. Add up all the outsides together, basically. This is a how do you find the perimeter? How do I find the perimeter? You add up all the outsides. If I'm thinking about the perimeter of a room, I'm going to draw the perimeter of this room, and I'm going to start by drawing this wall over here. This is the whiteboard wall. And then I'm going to get over to that red corner right there. I'm going to draw that red corner. Here's the door. And then I'm going to get over to where the flag is. I'm going to draw that way, go that way. And I'm going to get over to the yellow wall. I'm going to draw that way over here. Long yellow wall. Then I'm going to go to the green wall, which is like this. And then I'm going to get over to the orange wall, which is over here. And then there's a air conditioner right here. I have to walk around the air conditioner. And then I got to go into the air conditioner to the yellow wall. And then I walk over to this corner where the yellow vest is. And there's a little edge that comes out right this way. And then I can go that way. And then I can go back to the thing. The perimeter is the distance all the way around the outside. If I wanted to know the perimeter of this room, I would have to add up this wall plus the door wall plus the wall by the flag plus the yellow wall plus the green wall plus the orange wall plus around this air conditioner, because you can't go through it. That's what a perimeter is. Make sense? And I know you know that, but I need to explain that because I'm going to throw in a trickier question in a little bit. Let's start off with something easy. If I had a pentagon, and I'm going to call this a regular pentagon, meaning all 5 sides are exactly the same size. Okay, I'm going to draw that. Feel free to try to draw that if you can, as best you can. And on this perimeter of, I forgot to mention that in this particular pentagon, each of the sides is 2 inches. Like that. And what I want you to start thinking about, I'm going to put down over here, is the number of shapes that I have and what is the perimeter of those shapes. Here we go. Making a little table. I have a pentagon. How many pentagons do I have? And if I asked you to figure out what the perimeter of this shape is, it should be very easy. Don't say your answer, think about it. If I asked you what is the perimeter of this pentagon, be ready. Tell me what the perimeter is, say it out loud.
10 inches.
I think I heard a lot of people say 10. Some of you even said 10 inches. Wonderful, that is correct. Good job. Now here's where it gets tricky. That's the easy part. That's the part that everybody gets right. What happens if I add another pentagon to it? I know it looks like it's easy, but this is where it gets tricky. I'm going to add another pentagon to this pentagon. that has all sides of 2 as well. Bless you. And now we have 2 pentagons, and I want to know what the perimeter of 2 pentagons is. This time, I do not want you to say this out loud to me. This time, I want you to look at it and figure out what is the perimeter of these 2 things, but don't tell me, tell the person who's sitting next to you. If there's nobody next to you, in front of you, or behind you. Okay? And if you disagree, explain why. Discuss, please.
So one's 10, right? What's another one? 1 plus 1 is 2, right? Okay, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 19. Yeah, it is 18. I just miscounted. How did you get it? Yeah, I know. See, he told us this stuff right there when it's wrong. Told me wrong.
Okay, it sounds to me like most of you have had a good discussion. And so I am not sure what you are going to say. There's going to be one of 3 choices that most of you will say. Some of you are going to say 20. Some of you are going to say 18. And some of you are going to say 16. That's my guess.
Wait,
Okay? Okay, hold on. Let's do this as a... Oh, and is there anybody who thought of something else? Okay. What'd you say?
I was thinking 22 if we count the middle.
Oh.
As 2 sides.
As 22. Okay, so let's do this by a show of hands. How many of you said 22? Raise your hand. No? Okay. How many of you said 20? Raise your hand. 2. How many of you said 18? Raise your hand. And how many of you said 16? Raise your hand. Okay, we're all over the place. For anybody who's wondering, most people were trying to, the classroom half raised their hand for 16 and the other half raised for 18, and there was a scattering of 20s in the room. Okay? The actual perimeter, if I add up all the outsides, that's why I start with that definition. Let's start. Let me go and start right here. I'm going to put a starting point right here. Start. And I'm going to add up the outsides. 2, 4, 6, 8, 10, 12, 14, 16. The perimeter is 16. What ended up happening is this part of the perimeter anymore? This wall that's in the middle, basically. No, it is not. When we talk about perimeter, I made sure I started when I wrote it's only the distance around the outside. It doesn't matter what's going on in the middle of the room. We only care about the distance around the outside. We add up all the outsides to figure out what the perimeter is. Okay, so I'm hoping that the reason why we know, it's 16 is because we're using this definition. We have to know that definition to do it correctly. Let's do a third shape and see if we can figure it out. I'm going to add another pentagon. This time I'm going to add it this way. 2, 2, 2, and 2. That kind of came out kind of funny, but it's supposed to be all nice and perfect, and it's not. But nobody's perfect. We'll go with that. I add one more shape there. I want you to think about it. And I want you, in your mind, to figure out what the perimeter of 3 pentagons put together is. Wait, don't say it yet. And you have your thought. Let me hear what you all think it is, and you're going to say it out loud. Say it out loud. Go.
22.
I agree. I heard most of you say 22. You are correct at this point. You understand the definition, and that's what we're going to do on the worksheet today, basically. Now, at this point, I'm hoping that if I did a force shape, we will not have to graph it. We will not have to do a graph. I'm hoping that we can look over here at this table and you can mathematically figure out what the next number or the next perimeter would be. Can you figure out what this value is going to be without looking or drawing a picture? Can you now figure it out from just looking at the table? If you can, tell me out loud what it is going to be.
28.
Agreed. And this is part 1 of our essential question. Our essential question is how can I make a table and a rule from a pattern? And what did we do? What did we just do? We made a table from a pattern. And we labeled it number and perimeter. Okay? That's kind of our big idea number 1. There's our table. In our table, we're going to have to know different parts of the table. We're going to have to know which one is our dependent variable and which one is our independent variable. Which one depends on the other? Let me ask it this way. Does the number of pentagons depend on the perimeter, or does the perimeter depend on the number of pentagons? Think about it. Which one is dependent on the other? So which one is the dependent variable? Number or perimeter? Which one do you think? Say it out loud.
Perimeter.
Let's write dependent right next to the perimeter depends on how many pentagons you have. When we talk about dependent, that is basically our y-axis. I'm going to write y-axis above dependent, just to remind you, because we learned that last unit, but some of you still need practice with it, so we're going to hit it again. There's a lot of overlap in these units in Math 1. So what does that mean number is? Number is your independent. And which axis is that?
X.
So let's write that down. And that way we have x-axis, independence on the left, y-axis, dependent is on the right. That's important to us. Got to know those things. That's our table idea with our pattern. Now, let's write over here the second big idea, which is a rule. R-U-L-E. A rule means the exact same thing as an equation. Some directions on your worksheet will say write a rule. Some directions will say write an equation. It means the same thing. These two words mean the same thing. I'm going to write that there. Mean the same thing. What's a rule again? It means the same thing as writing an equation. When it says write an equation, it means the same as writing the rule. Just so you know, we'll use those interchangeably on the worksheets. Every rule has two parts. The first part of a rule is how much is the change. Let me write change down, C-H-A-N-G-E, change. How much is it changing by? That's what my question is. How much is it changing by? How much is it changing by? Every rule, and I probably should say not every rule, every linear rule. This unit, all of Unit 2, you're going to be figuring out between linear functions and other types of functions, okay? Every linear type of rule or equation will deal with change. And the second one Before I go to the second one, change. How much is this perimeter changing by?
6.
It's changing by 6. I know that's kind of hard to see, but what we're doing is we're adding, the perimeter changes by 6. We're adding outside pieces to our current piece. We're changing by 6. And I'm checking the dependent variable compared to the independent variable. Okay? That's what that is. That's the amount of change. Now, step 2. Where does it begin? Where is it before? I know this is a little different. This is kind of, you're going to learn how Mr. Paramo does things sometimes. Sometimes we go into the Mr. Paramo language before. B is going to stand for before, or where does it begin? When there are 0. When there are 0, what would it be? Question mark. When there are 0, what would it be? Where would it be before one number? What do you think it would be? Let's look at this pattern here. Okay? You've already told me how much it changed. I'm going to put a little example. It was 6, right? Now, where would it be before when there are 0, what would it be? If there was 0 on this table, what would the pattern be if it was at 0? Let's see if you can figure it out. If there was a number 0, what would our perimeter be based off of this pattern? What number? Now, some people are going to say, wait, I don't understand. How did you get 4? What? Can we go backwards? What happens when I go from 22 to 6? What am I doing? And if I go from 16 to 10, what am I doing? If I want to go to 0, I can do the same amount and subtract 6, and I can figure out that when there are 0 shapes, this would be 4. That's where it would be before the first shape. That's where it begins. And for linear equations, the change is basically something that we're going to call the slope, which is our m, and the before, which is our b, or where does it begin. And it's going to follow that equation that we've had before, which is y equals mx plus b. It's the same thing we did for linear functions. This is our m, this is our b. So we could write a rule for this. Let's see, y equals mx plus b. Let's write that down real quick. What was the change for this? What was the m? You told me already. Where is it before? Where is it when there would be 0 numbers, if that was possible here? Before. Now, I don't have a y and I don't have an x because one of these is independent, one of these is dependent. Remember how earlier we said that perimeter was our y-axis? Let's use p as our variable. Instead of y, I'm going to put p. P equals 6 times, instead of x, I want to use the letter n. This right here, p equals 6n plus 4, is our rule. It's our equation. Every rule you can check to see, well, is this rule the right rule? Let's find out. Let's take the number 2 and plug it into our rule and see if it works. If 2 is n, 6 times 2 is plus 4. What would that make the perimeter?
16.
Does it work? You can't just check one point. You have to check all, at least 3 points to see if it works. Let's see. Let's check. Let's plug in the number 1. 6 times 1 plus 4. Does that work? Let's plug in 4. 6 times 4 is? Plus 4 is? Does it work in 3 or more points? Yes. And if you're wondering why I'm checking 3, because sometimes your graphs might look like this. Dot, dot, dot. It might be something that is curved. And if you're only checking 2 points, you might think it's linear and you might think it works, but if you don't check that 3rd point, you'll never know if this equation, this rule works for all 3 points. So this is what you have to do. Let's do a different example. Let's put example, and I'm going to put a 1 in parentheses. This will be just like your first problem on your worksheet. Here is the pattern, or here's the shape. It's a rectangle. Sorry, it's supposed to be a perfect rectangle, but Mr. Promo can't draw very well. And this rectangle, I know it's kind of hard to see, so I'm going to zoom in a little bit, has a height of 2 and a length of 5. It's a perfect rectangle. And we have a number, and we have a perimeter. And you're going to be asked to do 3 things. You're going to be asked table, you're going to be asked to graph, and you're going to be asked to do a rule. These 3 things. Table, graph, and a rule. How many rectangles do you have? What's your perimeter? Good. Your perimeter is 14, and that's for 1 rectangle. And then what are they going to do? They're going to add a second rectangle to it, this. And it's the exact same size, where this is 5, that's 2, that's 2, that's 5. And they're going to ask you, what is the perimeter when there's 2? Ooh, I heard different answers. Let's look at it again. Let's make sure we all agree. What do you think the perimeter is? Okay, I've heard 18, and I've also heard 22. So which one is it?
22.
I'm hearing 18 and 22 again. Which one is it? I'm starting to hear more 18s than 22. Now, why is it 18? Let's add 5 and 5 is 10, plus the 4 and the 4. I only care about the distance around the outside. Don't forget, that's what the definition is. And then we can do 3, and I want you to go all the way up to 4, by the way. Only 4. We don't need to go more than that. Do you know what the perimeter is going to be for 3 and 4? You could draw it out if you want to. Do you have to?
No.
It's going to be the same change every single time. So what's the change going to, or actually, what's 3 going to be? And 4? Good job. Well done. And then we have now done the table. Now we're going to need to graph. So let's graph this function. When you graph, a lot of times they're just going to have this nice blank X and Y axis like this. And you're going to, I want you to make sure you are using some common sense here. Okay? I hope you know which one is your x-axis. Which one's going to be our x-axis? Number or perimeter? So I'm going to put number. And the number of rectangles that we have, or we can put rectangles if I want to, like that. 1, 2, 3, 4. I'm going to count by ones. Every line is going to be 1 unit. 1, 2, 3, 4. That makes perfect sense to me. That is using my common sense, is to know what I'm counting by. Make this easy on you. And then my y-axis. If I have a little scale, 1, 2, 3, 4. I have 4 little lines right there. I hope you're not going to count by ones. 1, 2, 3, 4. Am I going to count by 1, 2, 3, 4? That doesn't make sense to me. I wouldn't count by that. What do you want me to count by? What do you think?
10.
We can count by tens? Sure. You can count by nines? Sure. Count by eights? Sure. Let's do eights. 8, 16, 24, 32. When there is one rectangle, what was the perimeter?
14.
So I go up to where I think 14 is. That's pretty close to the 16. I put a dot. When there is 2 rectangles, what's its value? 18. I go up to where a little higher than 16. When I go to the third one, I go to 22, which is a little below the 24. And then 4, I go to 26. What type of graph am I doing? Do you remember what this type of graph is called? Discrete. That's something we learned in Unit 0. Why is it discrete? Because we're not counting 1.5. We didn't do 1.5 rectangles. We didn't do 1.2. We didn't do all the stuff in between. We're doing whole numbers. So I made my graph discrete. I still want you to make sure you know the difference. And as you're graphing, there we go. Make sure you've labeled it. Oh, wait, I forgot to label. What is this? This is the perimeter. Perimeter. Got to label it. I had rectangles down here. I had to label it. I had to rate the scale to get the graph correct. Now the last thing, I need a rule. The rule is going to be something like P equals blank and plus blank. And what's going to go in front of the n, I hope you remember, is the change. And what's going to go after, what are we going to add? That's going to be the before, or where it begins. I'm not sure if you know these two things, so I want you to discuss this with the person you're sitting next to. What goes here, see if you can figure it out.
I know what you mean. Yeah.
Thank you.
May I use the restroom?
Yeah. Someone.
Oh my god, as soon as I ask.
Okay, now that you've discussed what goes here, everybody say what goes here first.
4.
Agreed. What goes here?
10.
Agreed. I didn't hear anybody say anything else. If you do this right, we should be able to plug in 1 and it should work. We should be able to plug in 2. 4 times 2 is 8 plus 10 is 18 and it works. We should be able to plug in at least 3 of them and see if it works. If it does, now we have something we could use to find the 100th one if I want to. This will save us time if I need to find the perimeter and the number's really, really big and we don't have to draw the picture anymore. The rule saves us time when we have very big numbers to do. If I were to ask you to draw 100 of these, that would not make sense. Oh man, that's a lot of busy work. But if you know the rule and I said 100, you go 400 plus 10. Oh, it's 410 is going to be the perimeter. Exactly. It saves you time. The last thing we have to do, because you're going to be asked which one is dependent and independent, we already talked about that, is we're going to have to be asked, is it a function or not? Okay? So I'm going to write down the word function. Something is a function if each function, each x has its own y value. Something is a function if each x has its own y value. This earlier we learned as a graph passes the vertical line test. But it also, no x values repeat themselves. So as you look at this, you're going to be asked questions like, now that you know how to do the table, the graph, and the rule, is this a function? Does it pass the vertical line test? But sometimes you won't have the graph. So how can I tell here? Do any of the x values repeat? Do I have any of the inputs? The independent variables, do any of those repeat themselves? If they don't, it is a function. Do I have two number ones? Nope. Do I have two number twos or two number threes or two number fours? Nope. So these are functions. We're going to stop right there with our notes.